Hi, laddie. 'Tis I, chromosome, your genetic leprechaun. Aye, top of the chromosome to you. I'll be your guest host all week for Mr. Kovacs Bellringer. Aye, I'm so excited it me feel like dancing. Aye, laddie. Yeah, my official guest host this week, all week, is going to be my friend Chromosome. Hey, laddie, top of the morning to you. He's a genetic leprechaun. Hey, luck of the genes be with you. Yeah, because a lot of what we're going to talk about is just plain dumb luck. But hey, it's genetics. So let's get into it. All right. Hey now.
Mr. Kovacs class. It's Mr. Kovacs class.
You might learn a ton.
It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class.
Bacteria. Imagine how lucky you'd be if you were born a bacteria. Yeah. Bacteria are awesome. They reproduce quickly and have very simple genomes. They don't have a whole lot of genes. But one thing they can do is they can trade genes between each other, which is fun. And and of course they reproduce by doing mitosis. Mitosis. They copy themselves and split, and then you have two new baby bacteria where you only had one. You usually have one chromosome, they double it, they stretch out, they split, and now you have two cells with the same chromatin. It's not that different than what our cells do when they go through mitosis. We call that type of reproduction is called asexual, because there's no real mixing of genes. Asexual reproduction. And there's lots of ways that organisms have gone about asexually reproducing over the years. Let's take a look at a few. About an amoeba. Amoebas are a lot like bacteria in that they're single-celled, but they are eukaryotic cells. Right? But since they're only single-celled, when it's time for them to reproduce, they go through mitosis. We call that binary fission. Right? But they basically just go through mitosis. One cell splits into two, but first you copy the nucleus. We know all about mitosis. Right? How about planarians, flatworms, right? These guys are pretty cool. Platyhelminthes. They're awesome. They can also reproduce asexually, right? Like if you take a planarian and you cut it into pieces, each of those pieces will grow into a new planarian. There's no mixing of genes. They're all grow into clones of your original planarian. In fact, in school, we used to do experiments with planarians, but we stopped doing those because they were inhumane to the planarian, cutting them up into pieces like that and watching the pieces regrow. Or the hydra. The hydra is an animal, right? It's related to corals and related to jellyfish. And hydras live in fresh water and they have these stinging cells. Hydras are consumers, but when it's time to reproduce, they reproduce asexually. They just grow a new hydras off of their bodies. They do what's called budding. Budding. Right? You can see here's a mama hydra. She's gonna have 4 little baby hydras just by growing them out of her side of her body. They're all copies of mom. They're all clones. And of course, plants do this stuff too all the time. Did you know you could to grow a pineapple, you could just take the top of a pineapple and stick it in the ground and then you'll have a new pineapple? That's called vegetative repropagation. We use this all the time, vegetative propagation, to grow crops and to exploit plant crops and those kinds of things, right? Where you can grow a new plant from the root of the old plant. That's asexual reproduction. Asexual reproduction, right? There are lots of examples, but we've been talking about sexual reproduction, the mixing of genes. How did all that get started? Well, it's interesting. In some animals, it's kind of a little of both, right? Like, let's see, in bees, honeybees, right? A diploid female bee can go through what's called parthenogenesis, right? That's a queen bee. She lays an egg. If it doesn't get fertilized, the bees grow up to be males, right? They grow up to make sperm cells, okay? If she mates with a male and her eggs are fertilized, those bees grow up to be worker bees, right? Worker bees, okay? And then one of the worker bees gets fed the royal jelly and it becomes the queen. All right, so that's an example of, this is a species, honeybees, that can reproduce asexually and sexually. They can do both. They can pick and choose. I told you about my friends, the coral reef wrasse. I told you about them. They're the ones that can change their gender. They can go from making egg cells to making sperm cells if it's needed in their school. All right, pretty cool. And we talked about seahorses, who are, of course, fun because dad seahorses makes sperm cells, but he's the one who gets pregnant. Right? And then last week, of course, we talked about, at the end of the week, we talked about when is a cat on its birthday? Or is a cat already by the time it was in the womb, in the uterus, attached to its placenta? Or was it a cat even before that, when it was an embryo in the uterus? Or was it a cat when it first implanted into the uterus as a blastula, a ball of cells? Or was it a cat before that, when it was a bunch of ball of cells, we call them morula, moving through the fallopian tube? Or was it a cat the day it got fertilized? Right, the day that egg got fertilized and became a zygote? Or was it a cat before that, when dad made his sperm and mom made her egg? I don't know. That's for up to you to decide. When is a cat a cat? What do you think?